Assalamu alaikum, dear students. Today our topic is elevation in boiling point, a colligative property, in which we will discuss what is elevation in boiling point. We will derive the expression for elevation in boiling point. We will also determine the molar mass of the non-volatile solute by this elevation in boiling point. Also, we will try to solve the numerical based on the elevation in boiling point. What is boiling point? Boiling point of a liquid is the temperature at which its vapor pressure is equal to atmospheric pressure. तो वो टेम्परेचर जिस पर वेपर प्रेशर किसी लिक्विड का एटमॉस्फेरिक प्रेशर के बराबर बनता है तो वो टेम्परेचर उसका बॉइलिंग पॉइंट बनता है. फॉर एग्जाम्पल, वाटर boils at 373.15 Kelvin or 100 degrees Celsius, because at this temperature its vapor pressure becomes equal to 1.013 bar or 1 atmosphere. Now, as we have read that the addition of the non-volatile solute to the solvent reduces its vapor pressure. जब वेपर प्रेशर रिड्यूस होगा नेचुरली उसका बॉइलिंग पॉइंट इंक्रीज हो जाएगा. If we take, for the example, if we take aqueous solution of starch, starch is a non-volatile solute. We will dissolve starch in water and form its aqueous solution. This aqueous solution of the starch, it is vapor pressure, the vapor pressure of the starch solution at 373.15 Kelvin or 100 degrees Celsius is less than 1.013 bar or 1 atmosphere. With the result क्या होगा? It will not boil at 100 degrees Celsius or 373.15 Kelvin. So, in order to make this solution to boil, we have to raise its vapor pressure up to 1.013 bar or 1 atmosphere by raising its temperature above the temperature boiling point of the water. That means the boiling point of the solution will be higher, the boiling point of the starch solution will be higher than the boiling point of the water. The difference in the boiling point of the solution and its solvent from in which the solution is prepared is called elevation, gives us the elevation in boiling point. Now this can be explained graphically. Here I have plotted the vapor pressure of the solvent and the solution against the temperatures. This is the vapor pressure curve for the solvent, in which we have plotted the values of the vapor pressure against the temperature, and this is the vapor pressure curve of the solution in which we have plotted vapor pressure values against the different temperatures. From the plot, it is clear the vapor pressure of the solution is lower than the vapor pressure of the solvent at all temperatures. For example, we will take this temperature. At this temperature, the vapor pressure of the solution is like this. This is the vapor pressure of the solution. And at this temperature, what will be the vapor pressure of the solvent? So we increase it here, and this is the vapor pressure of the solvent at this temperature. Indicates that the vapor pressure of the solvent is higher than that of the solution. Similarly, if we take this temperature, at this temperature the vapor pressure of the solution is like this, and at this temperature vapor pressure of the solvent is like this, which is higher than the vapor pressure of the solution. Or in other words, we can say that the boiling point of the solution is higher than the boiling point of the solvent at all temperatures. Boiling point of the solution is higher than the boiling point of the solvent in which the solution is prepared. And the difference in the boiling point of the solution and the solvent will give us the elevation in boiling point. The vapor pressure at which the solvent, the vapor pressure of the solvent is equal to the 1 atmosphere, that is indicated by the temperature T0B. So T0B shows that the vapor pressure of the solvent is equal to 1 atmosphere. So T0B is the boiling point of the solvent. At this temperature, the vapor pressure of the solution is less than 1 atmosphere, because when the vapor pressure of the solvent or the solution becomes equal to 1 atmosphere, that means the solution will boil. That will give us the boiling point of that solvent or solution. So T0B is the boiling point of the solvent, because at this temperature its vapor pressure becomes equal to 1 atmosphere. And at this temperature the vapor pressure of the solution is lower. So in order to make the solution to boil, we raise its temperature, and at Tb the vapor pressure of the solution, this Tb shows that the vapor pressure of the solution becomes equal to 1 atmosphere. Therefore Tb is the boiling point of the solution. So the boiling point of the solution gets elevated from the boiling point of the solvent. The difference in the boiling point of the solution and the solvent gives us the elevation or the increase in the boiling point. So the elevation, that is del Tb, elevation in the boiling point, that we denote by Tb, is equal to T0B minus Tb, Tb minus T0B. Tb is the boiling point of the solution, and Tb is the boiling point of the pure solvent in which the solution is prepared. Now, it is found that this elevation in boiling point for the dilute solutions, it has been found experimentally that del Tb is directly proportional to M. What is M? It is molar concentration of solute in solution, or it gives us the molality of the solution, or we can write del Tb is equal to Kbm. What is Kbm? Kb is the constant called molar elevation constant or hygroscopic constant. For m is equal to 1, del Tb is equal to Kb. Thus, the molar elevation constant is defined as the elevation in the boiling point when the molality of the solution becomes unity, or we can write the molar elevation constant is the elevation in boiling point when molality is unity. What do you mean by molality is unity? That means when 1 mole of the non-volatile solute is dissolved in 1000 grams of the solvent. And what is now the unit of this molar elevation constant? We can write Kb is equal to del Tb divided by m, and the unit of del Tb is Kelvin. This is the difference in the boiling points of the solution and the solvent, so it is Kelvin, and this is mole per kg. Molality is the number of moles of the solute per 1000 grams or 1 kg of the solvent. Or we can write it as kg per mole. Mole upar aayega, per mole kg. So the unit of molar elevation constant is Kelvin kg per mole. So now we will derive the expression. This is the expression. So we have to derive this expression. It has been found derivation of equation. It has been found that the elevation in the boiling point is directly proportional to lowering of the vapor pressure del P. क्योंकि by the addition of the non-volatile solute, the vapor pressure of the solution decreases. ये हमने Raoult's law में पढ़ा है. So according to the Raoult's law, this del P is proportional to किसके? The lowering of the vapor pressure is proportional to mole fraction of the non-volatile solute. Solute, here we denote solute by B, alphabet B, or somewhere you will find it is denoted by 2, and the solvent by capital A, and somewhere it is denoted by the number 1. So this is mole fraction of the solute. Or we can say del Tb, the elevation in boiling point, is proportional to del P. Del P, this is lowering of the vapor pressure. Del P is proportional to mole fraction of the non-volatile solute. So we can write del P is proportional to Xb. Or del Tb is equal to Kxb. What is K? Where K is constant of proportionality and xb is mole fraction of solute. xb can also be written in the form of nb divided by na plus nb. What is Na? It is number of moles of solvent, and Nb is the number of moles of solute. For very dilute solution, since we are applying the Rot's law, because Rot's law says that the lowering of the vapor pressure is directly proportional to the mole fraction of the non-volatile solute, so we are taking the dilute solution. For dilute solution, Nb is very small as compared to Na, therefore Na, the number of moles plus of solvent plus number of moles of the solute are approximately equal to Na, the number of moles of the solvent. So we can write here Xb is equal to Nb divided by Na, or Xb is equal to Nb by Na. Xb is equal to Nb की जगह हम लिखेंगे Nb ही और Na की जगह Wa बटा Ma. Na is the number of moles of the solvent. The number of moles is equal to the mass of the solvent divided by its molar mass, or we can write Nb divided by Wa into Ma. Now we will put this value in this equation. We can write del Tb is equal to K Xb की जगह Nb divided by Wa into Ma. If Nb moles of the solute, Nb moles of solute are dissolved in 1000 grams of solvent, then here Wa is equal to 1000 grams. We are dissolving the number of moles in Wa grams of the solvent, and if we will take the number mass of the solvent is equal to 1000 grams, then Nb bata Wa is equal to M. This is the molality. What is molality? It is the number of moles of the solute dissolved in 1000 grams of the solvent, because we are taking Wa grams equal to the 1000 grams. So we will substitute this M in this equation. Del Tb, we will get del Tb is equal to K इन दो के बदले M into Ma, or we can write K Ma into M. Ma यहाँ लिखेंगे. K is the constant, Ma is the constant. What is Ma? It is the molar mass of the solvent. So for every solvent, molar mass is a fixed quantity. It is a constant quantity. So for this, we will write Kb into M. What is Kb? The Kb is the molar elevation constant. So we have derived this equation del TB is equal to KB into M, del TB is equal to KB into M. Now we have to calculate the molar mass of the non-volatile solute by the elevation in the boiling point. So determination of the molar mass. And determination of molar mass of solute by relative lowering of vapor pressure. In order to determine the molar mass of the non-volatile solute, suppose a known mass of solute, that is WB grams, having molar mass MB, is dissolved in known mass WA grams of solvent. Then we can write molarity as, here इक्वेशन हम लिख के रखेंगे, del TB is equal to mkb. So we can write molarity, it is WB by MB divided by WA. What's molarity? It is the number of moles of the solute dissolved per liter of the solution. But we are dissolving the number of the moles of the solute in WA grams of the solvent. And we have to, in order to calculate the molarity, it is the number of moles of the solute dissolved per liter of the solution, number of moles of the solute dissolved in 1000 grams of the solvent. We are dissolving it WA grams of the solvent. Now, in order to calculate the molarity, we have to dissolve it in 1000 grams. So, WB by MB is the number of moles of the solute, WA is the mass in grams of the solvent, and 1000 we have to calculate the value of molarity in 1000 grams. Or we can write M is equal to WB by MB into 1 by WA. ये न्यूमरेटर में है, इसका डिनोमिनेटर 1 आएगा, तो 1 by WA into 1000. And we substitute this value into the equation. What is the equation? Equation for elevation in boiling point, that is mkb. M molarity and kb is the molar elevation constant. So this equation will become del TB is equal to WB bata MB into 1 by WA into 1000 into kb. Or we can write 1000 kb into WB whole divided by MB into WA is equal to del TB. Thus, knowing the values of elevation in boiling point, molar elevation constant, mass of the solute, mass of the solvent, the molar mass of the non-volatile solute can be calculated, which we can write like this: mb is equal to, ये क्रॉस मल्टीप्लिकेशन करेंगे 1000 into kb into wb divided by wa into del tb. The molar mass of the non-volatile solute is equal to 1000 kb wb del tb into wa. If all the values are known, we can easily calculate by this equation, we can calculate the molar mass of the non-volatile solute. Now, based on this calculation, we will solve a numerical like this. The boiling point of the benzene is 353.23 Kelvin when 1.80 grams of the non-volatile solute was dissolved in 90 grams of the benzene. The boiling point is raised to 354.11 Kelvin. Calculate the molar mass of the solute. Kb for benzene is 2.53 Kelvin kg per mole. तो क्वेश्चन ऐसे है कि बेंजीन हमारा सॉल्वेंट है एंड इन बेंजीन वी आर एडिंग द नॉन वोलेटाइल solute. तो कितना हम 1.8 grams of the non volatile solute 90 grams of the benzene में डिसॉल्व करते हैं. So Wb is the mass of the solute, Wa is the mass of the solvent, that is 90 grams. तो बेंजीन का बॉइलिंग पॉइंट जो है वो from that gets increased after the addition of the solute from 353.23 Kelvin. So del Tb, the boiling point of the benzene is 353.23 Kelvin, and Tb, the boiling point of the solution, has increased from 353.23 Kelvin to 354.11 Kelvin. We have to calculate the molar mass of the solute, and also the molar elevation constant for the benzene is given, that is 2.53 Kelvin kg per mole. Now, mass of the solute, molar mass of the solute, we have to calculate. Mass of the solvent 90 grams, molar elevation constant 2.53 Kelvin kg per mole. Boiling point of the benzene, that is 353.23 Kelvin. Boiling point of the solution is 354.11 Kelvin. Now, how much is the elevation in boiling point? That is del Tb is equal to Tb minus T naught B. That is equal to 354.11 Kelvin minus 353.23 Kelvin, which is equal to, इसको हम इससे निकालेंगे 11 में से 3 8, 10 में से 2 8.0 Kelvin. Now we will apply the formula. Del Tb, the elevation in boiling point, is equal to what is the formula? 1000 kb Wb divided by Wa into Wma into Wa. This is the formula. Molar elevation constant, mass of the solute, mass of the solvent, molar mass of the solute, Mb. So we can calculate the molar mass of the non-volatile solute as Mb is equal to 1000 kb Wb whole divided by del Tb into, ये हम यहाँ ले लेंगे, into Wa. Substitute the values. 1000. Remember, अगर हम सॉल्वेंट जो है इन केजीज में ले लेंगे तब हमें 1000 नहीं लेना है. We are taking in grams, so we write 1000 grams per kg. We have to write the unit here. This is 1000 grams per kg, and kb is equal to, it is equal to 2.53 Kelvin kg per mole. And what is WB? WB is equal to 1.80 grams whole divided by del TB is 0.88 Kelvin into WA. How much is WA? It is 90 grams. That is equal to, अगर हम यहाँ kg लिखेंगे, here the kg means raised power 1, kg raised power minus 1, kg raised power plus 1. In case of the multiplication of indices, when the bases are same, powers are subtracted, तो ये और ये cancel हो जाएगा. It is gram here, it is gram here. It is Kelvin, Kelvin और Kelvin cancel हो जाएगा. Now we have 1000 into 1000 के साथ gram into 2.53. तो डेसिमल के बाद दो डिजिट्स हैं, वी विल राइट 253 डिवाइड बाय 100. सो यहाँ पर 0.88 डेसिमल के बाद दो डिजिट्स, तो 88 होल डिवाइड बाय 001 100 कैंसिल, सो वी विल राइट 88. इसके बाद पर मोल, इसके बाद 1.80, that is equivalent to 1.8, so that is 18 divided by 10 into G. So here in the denominator we have 90. ये ग्राम जो है 18 का वो कैंसिल हो गया. Now this is 9, 10, 2. ये ज़ीरो हम कैंसिल कर सकते हैं इन दो ज़ीरो के साथ. इट इज़ 11 2s और 11 3s कैंसिल, 11 8, 2 4s, 2 2s, 2 5s, and 5 into 3, that is equal to 15. 5 into 2 10, 11 whole divided by 2. यूनिट क्या रहेगा? ग्राम पर मोल. That is equal to 2 5 10, 2 7 15 14 plus 5, which is approximately equal to 58 grams per mole. So this is the molar mass of the non-volatile solute. So the molar mass of non-volatile solute is 58 grams per mole. Okay, thank you.